from what I can see in the course, you've gone over this stuff anyway, so I'm just going to quickly review some of the things from this first week about fractions. So you've learned that fractions are similar to decimals, right? And that the fraction 1/10 can be represented in various ways. So one way is the fraction like it shows up here. 1/10 is how we read it, right? Not sure why this isn't drawing. Here we go. Let me change this to the drawing. There we go. That'll do it. And let's tilt this back the way it's supposed to be. We can also plot it on the number line. If we have a number line between 0 and 1, and mark it off in equal sections of 10, then this first section here will show 1/10. We've gone 1/10 of the way across the number line. Or we can represent it in a picture too, or we call this pictorially, where we show that one piece out of 10 is shaded. Okay, so those are 3 ways to represent the fraction 1/10. But we can also write it as a decimal. I didn't show that here. So when in our decimal system, we have the ones and then the tens. I'm just going to write numbers here to show them. So if we have this, for example, we know that we have the ones here, and then the tens, and then the hundreds, and then the thousands, right? Then we have our decimal numbers, which is the unit we're working on. And on the other side of the decimal, we don't have ones anymore because ones represents a whole unit, a whole thing. So we start right off in this space with tenths. So notice the little bit of a difference there. We have the TH in there to show that it's tenths. And then we can go on to hundredths. And we can even go to thousandths. Now in grade 5, we don't deal with thousandths. We only go as far as hundredths. But I want you to be aware that it's there, right? That it keeps going on and on. The next one, just like if we go further on the left side, after 1,000, the next place value would be 10,000s. Same thing in the decimal place values. To the right, we have tenths, hundredths, thousandths, and then 10,000ths, and so on. So it's the same place value, just with that TH added in there to show that we're going to the right instead of to the left. Okay? So if we're going to write these as a decimal, we know 2/10 as a fraction would be 2 over 10. And as a decimal, we would just put 0.2, showing that the 2 is in the tenths place. For 3/10, 0.3. That 3 is in the tenths place again. And 0.9, 9 is in the tenths place. And the 0 before the decimal point tells you that the number is less than 1. So if we had 1 and 2/10, then that would mean we had one whole thing and 2/10 more. So we need to put the 0 in the front when we have a decimal to show that we have less than one thing. Otherwise, if you just do this, people might wonder, okay, is that a decimal or is that just a dot on the paper? What is that? And if you just do a decimal and then a 2, I will mark it wrong because it's not clear enough. You must have the 0 in the ones place, then the decimal, and then your decimal portion of the number. Okay? So looking at this, if we were going to put these decimal tenths on the number line, let's start with the smallest one, 0.2. I'm going to cross it off as we do it. We would count 1, 2, and 0.2. Actually, here, let me just see for a second. Yeah, I can just move it. So let me delete that. Let's erase that mark. And instead, I'm just going to grab this. I think I can grab it. Nope. They're not letting me grab it. Sometimes you can just grab it and move it down. But we're going to count 1, 2, and 0.2. There we go. Let me get my pen going again. 0.2 would be right at the second spot there. Counting on to find our 5, 3, 4, 5 would be right here. 0.5, halfway to the 1. 0.7, 2 more spaces, because 5 plus 2 is 7. And then 0.8 would be right over here. Okay, fairly easy to find them. It's the same thing as using a number line and if it was going from 0 to 10 and putting ones on there. We use the same process, just that now it's decimals instead of ones. So looking at these, if we're going to write the decimal for the picture, we know when we're talking about decimals, all of them are going to have a denominator of 10. Okay, so none of these pieces will have, for example, a denominator of 8 or 12 or anything like that. Whenever we're talking about writing decimals, all of our pictures will always be out of 10. So counting these, we know we have 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10 is going to be 8/10. So we'd write it like this. Here we have 7 that are shaded, so 0.7. And when they say write the decimal for the picture and you have pictures like this, they always mean for the shaded area, the shaded portion of the picture. Here it looks like we have 5. Is it 1, 2, 3, 4, 5? Yes, so we have 0.5. And here everything's shaded except 2, so that means we know, again, it's 0.8, same as the first one. Now here it gets a little bit trickier when we move to hundredths, because when we're looking at this, we're used to seeing this as 100, as 100, not 100th. When we're using blocks like this for fractions, it would mean that all of this whole thing equals to 1, not 100. So that can be a little bit tricky to wrap your mind around at first, but just consider that we're looking at each of these blocks as 100th of one whole piece. So just like the tenths, we can look at it as a fraction. 1 out of 100, one piece is colored out of 100 pieces in this square. We would write the words 100th. And then, just like I said at the beginning, we have the tenths here and the hundredths over here. Okay, so the hundredths is the second place to the right of the decimal. Now, you might be a little bit confused here. If it says write the following as a decimal, you might think that somehow you have to squish 28 into the hundredth space, but you don't. When you're writing numbers as a decimal, the last digit that you're given needs to be in the place value that you're given. So here, if our 8 is the last digit, then we're going to write 0.28. All right, we always have to put something into the ones digit, not the one, sorry, the ones gets a 0, into the tenths if they want us to write hundredths. So here, if we have 4 hundredths, if we wrote this, that would be wrong because that would put 4 in the tenths place. So that's not what we want. We need to remember that we need to put the 4 in the hundredths place. So 0 in the tenths, 4 in the hundredths. And here again, we have 70 hundredths because there's a 0 there, and in the last digit is a 0. Now we're going to put the 7 in the tenths place and the 0 in the hundredths place. So make sure that you keep that straight. Think about what it is. Think about how many of those tiny squares would be colored in. Here, 70 of the tiny squares, if we had a square like this, here where we showed 1/100th, if we had 0.70 or 0 and 70 hundredths, then that means 70 of the squares would be colored in. If we have 4/100ths or 0.04, then we would only have 4 of them colored in. Okay, keep those straight because sometimes it can get really confusing. Think about what it is that they're asking before you do it. And here it's just showing a number line. Notice here we have the decimal 10. The 1 is in the tenths place. So this number line can be compared, to the one that we looked at the very beginning here, right? So this would be 0.1, 0.2, and so on. All that they did in this other number line is they took all of these divisions here, each of these divisions, and I go back to it, and they split them up into 10. So now you have 10 pieces inside of each tenth. And if we have 10 pieces inside each tenth, and we have 10 groups of those, then we have 100 hundredths. And that's going to make one whole. So they ask here, where's 47 hundredths? Well, here's 40. If we count up, 41, 42, 43, 44, 45, 46, 47 hundredths would be right here in that spot. All right, so just a brief introduction to tenths and hundredths on that one. Now, if we're looking at this, and now it's asking how many tenths are shaded. So this is very similar to the square that we saw before, where I said each little square represents 1 out of 100, right? Well, if we have 10 groups of those, then that means that this would be 1/10, and this would be 1/10, and this would be 1/10. This is 1/10, and so on. All columns, this column here, and every following column would equal 1/10. So if we have 3 columns that are shaded, then how many tenths is that? It's 3/10. Now, if each column has 10 little squares in it, then we could count by tens and say we have 10, 20, 30, 30 hundredths shaded. So 3/10 is the same amount as 30 hundredths. Okay, that shows us how many tenths and how many hundredths are shaded. Now, if we have 3/10 and we want to write it as a decimal, remember that the decimal places are exactly to the right of the decimal. So 0 in the ones place, the decimal, and 3 in the tenths place. If we wanted to write 30 hundredths as a decimal, we need to make sure that 0 gets into the hundredths place. We would write 0 decimal, nope, not 0, sorry. We would write 0 decimal 3 0, and that puts the 0 in the hundredths place. Okay, pay close attention to how much which place value they're talking about. All right, if they want tenths, then they want you to stop at the tenths with nothing after it. All of this space should be blank. If they're asking you for hundredths, then you need to have something in the hundredths place value. All right. The other thing that you need to know is if we write this 0.3, we could write as many zeros as we want after it. It doesn't change the value. Like we saw in the picture here, It's exactly the same amount. If we write 3/10 or 3/100, when we have decimals, we can write as many zeros as we want. We could spend the rest of our life writing zeros after this decimal 3, and it won't change the value. It'll still be equivalent to 3/10. So we can write equivalent fractions and equivalent decimals for these amounts. If we look at this out of 10, and we look at each column, we have 1, 2, 3, 4, 5 columns that are shaded. If we look at it out of 100, counting all of the blocks individually, it would be 50 out of 100. Looking at it as decimals, let me just change colors here to make it a little bit clearer. This would be a 0 and 5/10, and this would be a 0 and 50/100. Notice when I said the decimal, this time I said and. This is the place where we say and when we're reading numbers. There are some people who would say this number, 350, and they would say 350. That's how I learned it when I was young. But since then, I've had to change because we've gone to a more standardized way of saying things, where this is now said 350, and this is said 0 and 50/100. So when you say and, you're saying there's a decimal place in there. If you told me to write the number 250, I would write it this way: 250, because the decimal means and, or and means the decimal. Okay? Let's look at the next one. Let's see if we can actually do the decimal first. We have 1, 2 columns that are shaded. So our decimal in tenths would be 0.2, or in hundredths, we would say it's 0 and 20/100. We could say 0 and 2/10 as well. I just still get kind of lazy sometimes and read it the way that I was taught to read it, as 0.2 instead of 0 and 2/10. And of course, the fraction would be 2 over 10 or 20 over 100. But it's still the same exact amount shaded, whether we use it as tenths or hundredths. So this just reiterates that. It says it over again. Although it's correct to read 0.7 as 0.70 and 50/100. Notice when I said the decimal, this time I said and. This is the place where we say and when we're reading numbers. There are some people who would say this number, 350, and they would say 350. That's how I learned it when I was young. But since then, I've had to change because we've gone to a more standardized way of saying things, where this is now said 350, and this is said 0 and 50/100. So when you say and, you're saying there's a decimal place in there. If you told me to write the number 250, I would write it this way: 250, because the decimal means and, or and means the decimal. Okay? Let's look at the next one. Let's see if we can actually do the decimal first. We have 1, 2 columns that are shaded. So our decimal in tenths would be 0.2, or in hundredths, we would say it's 0 and 20/100. We could say 0 and 2/10 as well. I just still get kind of lazy sometimes and read it the way that I was taught to read it, as decimal 2 instead of 0 and 2/10. And of course, the fraction would be 2 over 10 or 20 over 100. But it's still the same exact amount shaded, whether we use it as tenths or hundredths. So this just reiterates that. It says it over again. Although it's correct to read 0.7 as 0.7, it is not correct to read 0.70 as 0.70. We don't say 70 after a decimal unless we're saying 70 hundredths. Okay. Each digit after the decimal point would be read separately. So if we're reading 0 and 70 hundredths, we could also read it as 0.70. Okay, and then it's just got some examples there. So it's just two different ways to read the same thing, and you just have to get used to reading it the right way. And it's easy to get confused. Just be careful that you don't. That's basically what it comes down to. All right, so if we're looking at these numbers and we're comparing, it's not exactly easy to compare tenths to hundredths because tenths are bigger than hundredths. So how many hundredths is 4/10 equal to? And it would be 40, right? Just like we could say that this is 40 over 100, which is the same as 4/10. We could say that this is 38 over 100, right? So now if we add a 0 on the end here, remember I said if you add a 0, it doesn't change the value of it, right? It changes how it looks, but it doesn't change the value. Now we know here we have 40 hundredths, and here we have 38 hundredths. And we know instinctively that 40 is greater than 38. So if we have 48 hundredths, it's more than 38 hundredths. So 40, or 0.4 as it was originally written, is bigger than 0.38. All right, and on to our last slide set here. If we look at this, how many hundredths are shaded? Remember, all of the whole block, if the whole thing was shaded, it would be 100. So we're looking at something out of 100. And how many blocks are shaded? We can count it as 10, 20, 30. So we know it's 30 something. And here we have 2 more that are shaded. So 32 out of 100. So 32 hundredths is the same as 0 and 32 hundredths, like this. Notice what's in the tenths place and what's in the hundredths place. And that's what it's showing down here at the bottom. 32 hundredths equals 3/10 and 2 hundredths. The same amount. So if we look at these and we describe them as hundredths and then as tenths and hundredths, let's count how much is shaded here. I'm just going to write it over 100 to remind us our fraction is out of 100. We have 10, 20, 30, 40, 50, 60, 61, 62, 63, 64. 64 out of 100. So as a decimal, we would write 0 and 64 hundredths, making sure that that last digit ends up in the hundredth spot. Or we could write it as 0 and 6/10 plus 0 and 4 hundredths. All right, for B, let's switch colors. this lovely green color. Out of 100, we've got 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47. So as a fraction, 47 out of 100. To write it as a decimal, 0 and 47 hundredths. To write it as a product, or as a sum, sorry, not a product, we're not multiplying, as a sum of tenths and hundredths, 0 and 4 tenths plus 0 and 7 hundredths. They gave us a bonus down here. I think you're up for that challenge though. Let's see if I can bring it up enough to see it. We still have 100 blocks, but now the confusing thing is they're on their side. So instead of counting columns like we did at the top, we're going to count rows. So let's count these. We have 10, 20, 30, 40, 50, 60, 70, 80. So 80 something, 81, 2, 3, 4, 5, 85. And it's the same process. 0 and 85 hundredths. Or to split it into the tenths and hundredths, 0 and 8 tenths plus 0 and 5 hundredths. Changing colors again just to keep it from getting confusing. We'll go back to the purple. Same thing here. We're going to count the rows instead of the columns. Remember, columns always go up and down. Up and down for columns, side to side for the rows. All right, so we're going to count 10, 20, 30, 40, 50, 60, 70, 80. So out of 100, we have 80, 81, 82, 83, 84, 85, 86. So we're going to end up with 0 and 86 hundredths, or 0 and 8 tenths plus 0 and 6 hundredths. All right. Once you understand that it's all the base 10 system, all based on tenths, then it makes sense. Keep in mind that we are not talking about fractions that are out of 2. We're not talking about halves or thirds or quarters or any of those types of fractions. All right, we are only working with fractions out of 10 and out of 100. Those are what can easily be changed to decimal numbers because we have a base 10 system. All right. I'm pausing for a minute because I'm like, do I introduce this thought or not? I'm going to say it, but if this just confuses you, just ignore it. If we had a base 2 system, then we could say 1/2 equals something and put a decimal there. But because we do not have a base 10 system or base 2 system, we do not have a base 2 system. Our system is a base 10 number system. That's why this works for tenths and hundredths. And that's what we're focusing on when we talk about decimals in grades 5 and 6, both actually. When you get into higher grades, it'll be a little bit more confusing because you'll be working with different fractions, but don't worry about that yet, all right? Just focus on the tenths and hundredths. Now remember, here 10 cents is the same as a dime, and it's the same as 1/10 of a dollar. So if we say a dollar is one whole thing, we remember when we're writing dollars and cents, we put the decimal right after it, right? So this would be $1, and 10 cents in dollar notation would be like this. And I can't remember if I said it before. I don't think I did yet this year, but cent in French, cent equals 100. And it's actually pronounced cent. Different pronunciation, but it's the same spelling, same word. Cent is 100. And so in dollar notation, 10 cents is written like this. and 1 cent is 1/100th of a dollar. So again, in dollar notation, we would write it like this, 0.01 for 1 cent. Okay. Also, $0.73 can be represented in different ways. We could call it 7/10 and 3/100, or we could say 73 cents or 73/100. Make sure you get that TH in there. It's a little bit tricky to do, but make sure you do so that we know that you're not talking about 73 hundreds, because that's not what we're talking about, right? 73 hundredths would be 0.73 is what we would write, or 0 and 73 hundredths. Just like the ones place and tens place, this is what I've been emphasizing through the whole thing. There is the tenths place and the hundredths place in decimals. Okay, that's just what I've been saying throughout the whole thing. So that's really nothing new to present on that slide. We can also, because we use the metric system, this is the beauty of it. The metric system is a base 10 system. Like I was just saying, base 10, that's what our money is. That's what our measurement is. In the United States, they use the imperial measurement system, which uses the pints and quarts and cups and miles, and I can't even think of what else their measurements are, but they are not base 10. That's what makes our measurement system an easier way to measure, and that's why most of the world uses the metric system. So if we look at 1 meter as being our base, just like $1 is the base in our money, if we want to know how many centimeters are in a meter, we know that there's 100 centimeters equals 1 meter. So what fraction of a meter is a centimeter? 1 centimeter is the same as 1/100th of a meter. So it would take 100 of them. If we laid them all out, if we took that square that we used before, if we take one of these squares, if we laid all of these little squares out individually, side by side, and measured them, if each one was a centimeter, and we laid them all side by side, then that would equal 1 meter. Where am I here? There we go. So 100 of them, just like 100 cents equals $1, 100 centimeters equals 1 meter. So if we have 5 centimeters, it would be 0.05 or 5/100ths of a meter. And then you can know too that if we have 17 centimeters, then it will equal 17/100ths of a meter. If you get confused, think of a meter as that 100 square that we had at the top. And each centimeter would be 1 centimeter of that. Okay, same thing. Our money, our measurement are all base 10, just like our number system. And that's what makes it easy to use. All right. So that's basically what I wanted to cover for this week. So I hope that all makes sense. And if you have any questions, feel free to message me. And I look forward to seeing your work in the course and seeing how you do. All right. Talk to you later. Bye.